In this video, we will explore the sum, difference, and double angle formulas or identities. Have you ever wondered how we can find the exact value of sine 75 degrees or cosine 15 degrees without using calculator? These sum and difference formulas or identities are the key, because sine 75 degrees can be written as sine of 30 degrees plus 45 degrees, and cosine 15 degrees can be written as cosine of 45 degrees and 30 degrees. And as we know, these 30, 45 degrees are special angles. So the first expression is using sum angle formula or identity, while the second expression here is difference angle formula or identity. So let us explore the sum and difference formulas. Let us start in the sum and difference angle formula for sine. Take note that this is not equal to sine of alpha plus and minus sine of beta, meaning you cannot distribute the sine in these two angles. So let us present the identity for this. The sine of alpha plus and minus beta is equal to sine of alpha cosine beta, then plus minus cosine alpha sine beta. So to memorize this, you will just write the angle in this order: alpha, beta, because alpha is the first angle and beta is the second angle. And then for the function, sine, cosine, and sine. You can see that there's a symmetry here. This is cosine, cosine, and this is for sine. And then the sign here, which is plus, then this is plus. If this is minus, then this is minus. So it's the same sign. Then for the sum and difference angle for cosine, take note that this is also not equal to cosine alpha plus minus cosine beta, meaning you cannot distribute also. So this identity is equal to cosine alpha cosine beta, then minus plus sine alpha sine beta. So you can see that the angle is in the same order. This is alpha beta, so alpha beta, but the function is cos, sin. And the sign here, if this is plus, then this is minus, and if this is minus, then this is plus, meaning they should have an opposite sign. And then for the next function, which is tangent of sum and difference angle formula, this is optional, so you can use this formula. So you may encounter tangent of alpha plus and minus beta in the homework, so you can just make use of this. Now, going back to this sine and cosine of sum and difference angle formula, you can easily memorize this by having a rhyme. Like for example, for sine, sin cos sin, then cosine is cos cosine sin. Again, sin cos sin, then cos cosine sin. Sine, same sign. For cosine, opposite sign. So that's it. Now for the double angle formulas, like the double of alpha, so it means it's 2 alpha. So we have a sine of 2 alpha, which is equal to the product of 2 sine alpha and cosine alpha. This sine 2 alpha is derived from the sum and difference angle formula, but we will not derive anymore. So you need to memorize this sine 2 alpha, which is equal to that, and any identity, because we will not give any formula sheets in the exam. So for the cosine to alpha, we will have equal to cosine squared alpha minus sine squared alpha. You can easily memorize the double angle for cosine because this is related to Pythagorean identity. Remember, when this is plus, cosine squared alpha plus sine squared alpha, that is equal to 1. So when this is a minus, starting with cosine squared alpha, so that is a double angle for cosine. Actually, there are 3 equivalent identities for this. So the first identity is in terms of cosine and sine, but the second identity equivalent for cosine to alpha is in terms of cosine only. So this is equal to 2 cosine squared alpha minus 1. Another one is in terms of sine only, which is equal to 1 minus 2 sine squared alpha. So you can use any of this identity. So usually you can just memorize the first one. So cosine squared alpha minus sine squared alpha. And then for the double angle for tangent, this is also optional, but you can use this formula in case You can see this problem in the homework. For this example, we can see two angles alpha and beta. The condition for alpha is that sine alpha is equal to 4 over 5, where tangent alpha is less than 0. And cosine beta is equal to negative square root of 5 over 5, where beta is between pi to 3 pi over 2. Then, our aim here is to find the exact value of the following trigonometric function. So the first one is sum angle formula for cosine. The second one is difference angle formula for sine. The third one is double angle for cosine. And the last one is double angle for sine. So let us analyze each angle. So for alpha, so we have sine alpha is 4 over 5 and tangent alpha is less than 0. So first, we need to locate where is the terminal side of the angle alpha. Since the sine alpha here is a positive value, so we know it's positive in the first quadrant and in the second quadrant, and tangent is negative on the second. So the angle alpha is in quadrant 2. Since the alpha is not an acute angle, so we have to define the reference angle, which is this. This is the alpha sub r, and let us create a right triangle from there. Then the opposite of this alpha sub r, or reference angle of alpha, is y, and the adjacent is x, and this hypotenuse is r. Then to find for the values of x, y, r, so we have to use the given of sine alpha, which is 4 over 5. And based from the definition of sine alpha, it is equal to y over r. And we know that y is positive because the angle is in quadrant 2. Y is positive here, so y is equal to 4. And the r value is always positive, which is equal to 5 because it is hypotenuse. So the missing value here is x, and we know that the angle is in quadrant 2, meaning the x is negative. So in the formula for x, we have to attach the negative sign. So negative is square root of r squared minus y squared, which is equal to a negative 3. Take note again that x is negative in quadrant 2. That's why you have to make sure that in the formula there's a negative. So we now have the value of x, y, and r. So since we have a sine alpha, then we can find for the cosine alpha, which is x over r, which is equal to negative 3 over 5. Then let's proceed to beta. So we have a given cosine beta, then our aim is to find for sine beta. So we have to locate the terminal side of beta. Since here, the beta is between pi to 3 pi over 2, we know that pi is 180 degrees, it's here, and 3 pi over 2 is 270 degrees, which is there, meaning the beta is directly given, which is equal to between 180 to 270, meaning it is in quadrant 3. And to confirm, the cosine beta is negative, and it is true that cosine is negative in quadrant 3. So our angle is in quadrant 3. Since the beta is more than 90 degrees or not an acute angle, so let's define again the reference angle. So this is the reference angle. And let's create a right triangle here, attaching in the x-axis. So this is the right triangle. So the opposite here is the y, this is the y, and this is the x, and this is the r. And then after that, we can find these values by using the given, which is cosine beta equal to negative square root of 5 over 5. And the formula or the definition of cosine beta, we know that that is x over r. X over r. So, meaning I have to put the negative in the numerator because this represents the x, because r should always be positive. So this negative cannot be in the denominator because denominator is the r value. So x is equal to negative root of 5 and r is equal to 5. And it is consistently correct because we know that in the third quadrant, x is negative and r is always a positive. So the missing value here is the y, and the sign of y in quadrant 3 is also negative, so that's why we have to attach the negative in the formula. So negative is square root of r squared minus x squared, which is equal to negative 2 root of 5. So take note again that y is negative in quadrant 3. So that's why we have to put negative in the formula. So now, since we have already the XYR, so we can find the sine of beta because we already have given cosine beta. So sine beta is y over r, which is equal to this value. Now to continue, since we have a given sine alpha and we found cosine alpha already, and then given cosine beta, we found sine beta. So now we can find the following trigonometric expressions. So the first one is some angle formula for cosine. So we'll be using cos alpha, cos beta, then minus sine alpha, sine beta. So take note that you have to make sure that alpha and beta were written in order, alpha, beta, alpha, beta. Then cosine is cos, cos, sin, sin, then opposite sign, plus, then this minus. So you would just substitute the values for this and make sure that you substituted correctly. So this is the substitution. Then after that, you would just put in calculator, then you will get 11 square root of 5 over 25, and make sure the answer is in simplest form and not in decimal places. Then for sine of alpha minus beta, so write the formula, sine alpha cosine beta minus cosine alpha sine beta. So for sine, we have sin cos, cosine, alpha beta, because the first angle is alpha, second angle is beta. Then this is difference, this is minus. For sine, we should have the same sign, so this is also minus. Then substitute the values for each. Then after that, put this in calculator, it will give you this, and make sure that the answer is in simplest form. Since in 10 and 25 there's a common factor which is 5, so the final answer must be this. Then the next one is the double angle for cosine, and the double angle for cosine is cosine squared alpha minus sine squared alpha. Then substitute the values. So we have a square root of this minus a square root of 4 over 5. Then put this in calculator. Then it will give you negative 7 over 25. Then the last one is the double angle for sine, which is the product of 2 sine alpha and cosine alpha. Then substitute the values again. Then multiply all together. Then the answer is negative 24 over 25. As a reminder, if sine theta is equal to 2 over square root of 5 and cosine theta is equal to negative 1 over square root of 5, and we're finding for sine 2 alpha, which is equal to this, never substitute 2 over square root of 5 in the angle theta, because theta is not equal to 2 over square root of 5. This 2 over square root of 5 is the value of the whole sine theta, the expression sine theta, meaning the correct one is putting 2 over square root of 5 in the sine theta, and the cosine theta is negative 1 over square root of 5. Again, never put this value in the angle because that's not the value of the angle. These two are the values of sine theta and cosine theta respectively. Now for the next example, let cosecant theta equal to square root of 5 and theta be a positive acute angle. Then find the exact value of the following. So here there's a double angle for sine, double angle for cosine, the difference of sine and cosine, and then this is difference angle formula for sine, and this one is cosine of 3 pi minus theta. You can also use the difference angle for cosine, and you can also use RAT here, the reference angle theorem, because this is 3 pi. And then for the last one is you can use difference angle formula for sine, or you can use the cat because this is pi over 2 minus theta. So let us analyze the theta. Since the angle is a positive acute angle, so meaning it lies in quadrant 1. So since the theta is in quadrant 1, we don't need for the reference angle because the reference angle will be the same. So we can directly create the right triangle from here. And then after that, we can define the y, which is the vertical distance, and the x is the horizontal distance, and the hypotenuse is the r. Then to find for this x, y, r, we can make use of this trigonometric function given, which is cosecant theta is equal to square root of 5. Then let us define this cosecant, which is opposite of sine. So meaning this is equal to r over y. So we will write this is square root of 5 as a fraction, square root of 5 over 1. And we are sure that r is positive is square root of 5 and the y is equal to 1. So take note both of these are positive because it's in the first quadrant. Then the missing value is the x. So we have here r equal to this square root of 5 and y is 1. Then the formula for x, we know that the angle is in the first quadrant, so we know that x is a positive. So x is equal to the square root of r squared minus y squared, which is equal to positive 2. So since we already have the values of x, y, and r, so we can now find the sine theta, which is equal to 1 over square root of 5. Actually, the sine theta, you can find this by getting the reciprocal of square root of 5 over 1 because sine theta is reciprocal of cosecant. Then another one is the cosine theta, which is equal to x over r, which is 2 over square root of 5. So I didn't simplify this yet because this is not yet the final answer. We just need the sine theta and cosine theta to solve for the needed trigonometric expression. So now we are ready to find all this. So for the double angle for sine, so writing the formula for this, so we now have equal to this. So we have to substitute the values for these functions and then put this in calculator and then you will get 4 over 5. Then for the cosine 2 theta, double angle for cosine, we have this formula and then substitute the values for each. Then putting this in calculator, you will get the value of 3 over 5. Then for letter C, sine theta minus cosine theta, substitute the value of sine and the value of cosine. So get the difference between them, so the answer will be equal to this. So your answer must be in simplest form or no radical in the denominator. Then for letter D, we have sine of theta minus 5 pi over 2. We can make use of the difference angle formula for sine, which is sine theta cosine 5 pi over 2, then minus cosine theta sine 5 pi over 2. So let us check the identity or the formula, theta and 5 pi over 2. So we have theta, then 5 pi over 2, theta, then 5 pi over 2. Then since the function is sine, so we have sine, cos, cos, sine, sine, same sign. So if this is minus, then this is minus. Then just substitute all the values here. Then we will get 1 over 5, 1 over square root of 5 for the sine theta. Then the cosine 5 pi over 2 in calculator, you will get 0. Then the cosine theta, which is equal to 2 over root of 5. Then the sine 5 pi over 2 using calculator is equal to 1. Then after that, since the first term is 0, so the answer will be equal to negative 2 square root of 5 over 5. So we already simplified this 2 over square root of 5. Then to continue, so we have cosine of 3 pi minus theta. This 3 pi minus theta is a difference angle formula for cosine, so we can use DAF or difference angle formula. So we have cosine 3 pi cosine theta, then plus sine 3 pi sine theta. So let us check. 3 pi is the first angle and theta is the second. So 3 pi and theta, 3 pi and theta. Then cosine is cos, cos, sin, sin. And then since cosine, we should write the opposite side. If this is minus, then this is plus. Then in calculator, cosine 3 pi is equal to minus 1. Then cosine theta is this given. And then plus sine 3 pi is 0 in calculator, and then sine theta is given, which is 1 over root of 5. So since the second term is 0, so you will just multiply this, then the answer or the final answer is negative 2 square root of 5 over 5. So we can have another solution here using reference angle theorem or RAT, since 3 pi minus theta is in quadrant 2, so this cosine of 3 pi minus theta is equal to The sign of cosine in quadrant 2 is a negative, so it's equal to negative cosine of the reference angle because the reference angle of 3 pi minus theta is theta. So we just need to substitute the value of cosine theta, which is 2 over root of 5. So the answer will be equal to this, which is similar to the first solution. So you can use any of this. Either you will use the RAT or you will use the difference angle formula. Then for the last one is sine of pi over 2 minus theta. The easiest solution here is using the cat. Take note that pi over 2 minus theta, this is less than pi over 2 or less than 90 degrees. So that's why we can use the cat here. In using cat, the cofunction of sine is cosine, and then it's equal to the cosine of the second angle theta. So the cosine theta is given, which is 2 over root of 5. So rationalizing it will be equal to this value. So another solution for this is you can also use the difference angle formula for sine. Now for the next example, use the figures below to evaluate each function given that the function f is cosine x and g of x is equal to sine x. So the condition for alpha is using this circle with equation x squared plus y squared equal to 5. Take note that 5 is r squared. And the point on the terminal side of this angle theta is a comma 2. So this point is xy. Then for alpha, so this circle is with equation x squared plus y squared equal to r squared. So r squared is equal to 1. And the point on the terminal side of alpha is negative 1 fourth comma b. So this is the point xy. So we're looking for g of theta. When you say g of theta, you will substitute 2 theta for every x in the function g. So it means to say g of theta is the same as solving sine 2 theta. Then for f of alpha plus theta, you will substitute alpha plus theta for every x in the given function f. Meaning this f of alpha plus theta, it is the same as solving cosine of alpha plus theta. So to solve this, let us analyze each figure. So for the first figure is for angle theta. So take note that this A2 is the point xy, and this equation is the equation of the circle, which is x squared plus y squared equal to r squared, meaning this r squared is equal to 5, and this point is the point in the terminal side of the angle theta. So for this theta, we have the given, which is y equal to 2, because the y value is 2, the x is unknown, so we're looking for x later. And since r squared is equal to 5, then r is equal to square root of 5. So to find for the value of x, since x is from the angle theta, which is in quadrant 2, the x is negative. So the formula for x, we should have a negative square root of r squared minus y squared, which is equal to negative 1. Take note that in the formula for x, you should attach the negative because x is negative in the quadrant 2. Don't forget that. So we now have the value of x, y, and r. So we can find the sine theta, which is equal to y over r, or 2 over square root of 5, and the value of cosine theta, which is x over r, or negative 1 over square root of 5. So we will not simplify this because this is not yet the function that we're looking for. We will just substitute this in the unknown expression. So this is for theta. Now, let's move to alpha. So in alpha, so we have a point xy, which is negative 1 fourth comma b. So y is unknown. And the equation of the circle is x squared plus y squared equal to r squared, meaning r squared is equal to 1. So r is 1. So for alpha, we have the given value of x, which is negative 1 over 4. And y is unknown because y is b here. So y is unknown. And the r value, because r squared is equal to 1, then r is equal to 1. So to find for y, we have to check the alpha. The alpha is in quadrant 3, and we know that y value is a negative. So in the formula, we have to attach the negative again. So y is equal to negative square root of r squared minus x squared, which is equal to the negative square root of 15 over 4. Take note that y is negative in quadrant 3. So let's find for the sine alpha. Sine alpha is y over r. So y is this fraction, then divided by r, which is equal to 1. And then for the cosine alpha is x over r. Since r is equal to 1, so cosine alpha is simply equal to x. So these are the two values that we need to find for the trigonometric expression. Since we are done finding for sine theta, cosine theta, and sine alpha, cosine alpha, so we can continue solving this since we're finding for g of 2 theta and f of alpha plus theta. So for letter A, g of 2 theta, meaning we will substitute 2 theta for every x in the given function g. So this is equal to sine of 2 theta. And then this is now double angle for sine, which is equal to this identity, 2 sine theta, cosine theta. Then after that, we would just substitute the value for sine and cosine of theta. And then multiplying this, so we will get negative 4 over 5. Then for letter B, we have f of alpha plus theta, meaning we will substitute this alpha plus theta in x for every x in the given function f. So we have cosine of alpha plus theta. So this is now some angle formula for cosine, which is equivalent to cosine alpha, cosine theta, then minus sine alpha, sine theta. Cos, sin, alpha theta. So alpha theta. Make sure that the angle is in order. Then cosine means opposite sign. If this is plus, then this is minus. Then substitute the values. So for cosine alpha and cosine theta, we have these two values. Then minus the sine alpha and sine theta, which is equal to this. Then press this in calculator. Then it will give you this, which is equal to this expression in simplest form.